This is a problem from chapter 13. So for this one, we have a block that's on a surface, and it has some forces acting on it. So it's got a 300 Newton force acting to the left, and then a 500 Newton force up here. And we know the direction of that 500 Newton force. It's the ratio is down 3/4, so 3-4-5 relationship. The block is 10 kilograms, and we're supposed to find the velocity when t equals 2 seconds if the velocity equals 0 at t equals 0 seconds. Assume a smooth surface with no friction. So. How we start these problems, or we'll just start with drawing the free body diagram and the kinetic diagram, since now we're into things that are moving. So for the free body diagram, I'm just going to draw the crate and put all the forces on there. So we've got 300 newtons. We have the weight of it, which is 10 kilograms times 9.81 meters per second squared. So we know weight's mass times acceleration due to gravity. We have that 500 Newton force. And we have a normal force. And we know a little bit, let's see, G is going to be at the center, and we know this is the 3, 4, 5 triangle. So now we can draw the kinetic diagram also. So we have this, and G, and then we have mass times the acceleration in the x direction, and that mass is 10 kilograms, so that would be 10 kilograms times a sub x. And we want to find that velocity of the block. So now that we have this drawn out, we're interested in the velocity. So if we find the acceleration of the block, then we can find the velocity, because we know those relations. So if we sum the forces in the x direction, that's going to equal the mass times the acceleration in the x direction. So we're looking at the left, the free body diagram is that sum of the force in the x, and then m times a sub x is on the right side from the kinetic diagram. So for this one, we're looking at the free body diagram. We want that x component of the 500 Newton force, so 4/5 times 500 newtons. Both the weight and the normal force are in the y direction, so we don't worry about that. And then minus, and then the 300 newtons is all in the x direction, and that equals 10 kilograms times a sub x. If we multiply that out, we get a sub x equal to 10, and it's kilograms times newtons, which newtons are kilograms meter per second squared. Sorry, that's wrong. So it's newtons, and then we're dividing by that kilograms, because it was newtons on the left side, and then we divided by the kilograms. So the kilograms go away, so we get the acceleration, the x equal to 10 meters per second squared, and the units are right. That's just a way to sort of check ourselves. So that's getting us towards our answer, and they asked us for the velocity. So a sub x equals v sub x over t. So the velocity equals the acceleration times time. and we know it starts at 0. And so this will be 10 meters per second squared times 2 seconds. So that gives us 20 meters per second. Those cancel out to the right. So now we found the velocity.